Hello everybody and welcome back to the final question on the 2003 Galois paper. That's right, it's question number 4. Hopefully you've had a chance to take a look at it, and I'm going to go through it right now so we can compare answers. Alright, question number 4. This should be the hardest question on the paper. That's usually the way they have it structured. It goes easiest to hardest in most cases. Although sometimes it's a toss-up between the last two. I mean, that game question certainly took me a while. Anyway, so what does question 4 have to say? In the diagram, ABCD is a square, and the coordinates of A and D are shown. So we can see pretty quickly they both have a constant x term, so it's very easy to see what the side length of AD is. And AB, DC, and CD must also be 8 minus 4, which is 4. So this square is going to have a side length of 4. And because AD is parallel to the y-axis, and it's going to have a right angle at A, then AB and DC are both going to be parallel to the x-axis. These are little things we can note and probably write down as part of our solutions, just to help us figure things out. Alright. So we've got a square, and now what does question A say? The point E, which has x-coordinate A and y-coordinate 0, so it lies exactly on the x-axis. So we have the point E so that CBE and ABE, these are triangles, lie entirely outside the square ABCD. Okay? For what value of A, they say value, not values, is the sum of the area of the triangles CBE and ABE equal to the area of the square ABCD. Okay, so first we need to figure out the area of the square. That way we know what we're shooting for. And then we need to figure out each of CBE and ABE in terms of little a, the x-coordinate of E. And then we'll have to equate those two, and hopefully we'll be able to figure out what A is. So let's draw ourselves a little picture. We'll put the y-coordinates or y-axis over here. Put the x-axis along here. So we have A, and that was 1, 4. D, that was 1, 8. And I'm going to write so it's clear we have a side length of 4. So B has coordinates, well, it's in the x direction, so we need to add 4 to A, because it's not on the other side of the y-axis, so it's definitely going to be positive values. So B has coordinates 1 plus 4, 4, which is really just 5, 4. And C has coordinates, it'll be 1 plus 4, 8. So it'll be 5, 8. We're going to write B inside the square just because a lot is taking place outside the square. Alright. And we have some point down here, E, A0. And we have these two triangles. And since we know the side length of ABCD, so we get ABCD has area of 16. So that's what we're shooting for. Alright. So how are we going to figure out the areas of these triangles? Or do we even get to figure out the area of these triangles? Is there some way to only consider it using both the triangles at the same time? And that happens occasionally in questions where you can't actually figure out an individual thing, but combined you can figure out the total of a bunch of things. You'll see that in average questions where they have a couple averages, or a couple values unknown in the average. So if we were to extend BC and AB, we would get lines here that are parallel to the x-axis and the y-axis. Okay. And this length here, which incidentally is the height of CB. So let's give these things names. Extend BC and AB. We'll have point I on AB. So AB is perpendicular to IE. And we'll have J on BC so that it makes a right angle when we connect it up with E. Alright, so we have this one's I and this one's J. Okay. So I will have coordinates, we'll call it I4, and J will have coordinates, looks like we have 5 and J. Okay. So since AB is parallel to the x-axis, and BC is parallel to the y-axis, it is not hard to see I will actually share the x-coordinate with IE, or with E, because AB is parallel to the x-axis, so EI being perpendicular to AB has got to be parallel to the y-axis, so they will share the same x-coordinate. So I is at A4, and by similar reasoning, J is at 5, 0. Okay, so we can actually write those in. 5 and 0. Okay. Now notice that we have a height of our triangle ABE and we have a triangle of CBE. Okay? I and J were chosen specifically so that they would be heights. Okay? That's why we chose I and J so they'd be perpendicular to the extensions of AB and CB. Because then we can let CB be the base, and we know the base has is 4. And we know AB is the base of ABE, and it has a length 4. So if we can figure out EI, which we should be able to, it's 4 minus 0, so it should be 4. And we can figure out the height of CBE, it's just the length of JE, which is going to be A minus 5. We should be able to put all this together. So the length of IE is 4, and the length of JE is going to be A minus 4. Or sorry, A minus 5. Now the area of ABCD, we've already marked that that's 16. And that's going to be, we want it to be the area of ABE plus CBE. And that's 1/2 base times height plus 1/2 base times height Well, AB is length 4, and IE is length 4. And CB is length 4, and JE is A minus 5. So when we work that out, we get 8 plus 2 times A minus 5. Well, that's 8 plus 2A minus 10. That's 2A minus 2. So if we rearrange, 16 is equal to 2A minus 2. A is going to be 16 plus 2 divided by 2. 18 over 2, which is going to be the value of 9. And is that what we were asked for? It's always important to actually ask these to answer the question that you were asked. For what value of A is the sum of the areas of the triangles equal to the area 16? All right, so we plugged in the equation for the area of the two triangles, and we got something in terms of A. We solved for A, and we got a value of 9. Fantastic. Okay. So, is that all? Is that all that's left? Did that all work correctly? Yeah. So I will make a note, just because in the question they say that CBE and AB have to lie entirely outside of the square. What we could have had, so I'll just do a little mock diagram here. We could have had some point over here in the negatives, and that would have, you would have still been able to make the triangles, and you still would have had them give an area of 16, but you would have had a less than 5, and so here we assumed A was greater than 5, and that's what made all this work out. If you had A less than 5, you still could have found an appropriate value for A, but it would have had the triangles overlap, and that was not allowed. Alright. So that's just something I wanted to clear up really quickly, that there were two different A values, but only one of them, A being greater than 5, so in this case A is 9, has the triangles lying completely outside the square. Alright. So, B. The point F is on the line passing through the points M and N. Okay, so immediately I want to know what is that line. That way I can figure out what F looks like. It'll be X comma some formula in terms of X. So the point F is on that line so that the triangles CBF and ABF lie entirely outside the square. Okay. Determine the coordinates of the point F if the sum of the areas of the triangle CBF and ABF equals the area of the square. Alright, so very similar thing, except our point is not lying on the x-axis. It's going to have some other formula. So, first thing I want to do is to figure out what is the line passing between M and N. Okay, well, I know the coordinates for M and N, so it's very easy to get the slope. It's the y-coordinate of N minus the x-coordinate of M, and then the y-coordinate of N minus the y-coordinate of M, x-coordinate of N minus the x-coordinate of M. That's the slope. So that's 3 over 6, so it's 1/2. So we have a slope of 1/2, that's great. So y equals mx plus b, and we know that n satisfies this. So we know that 12 is equal to, not 12, it's 2. 2 is 1/2 12 plus b. So that's 6 plus b. It's not hard to work out. B is going to be -4. So our line is y equals 1/2 x minus 4. And we can do just sort of a little mental check. If we plug in 6 here, we'll get 3 minus 4, so that'll be negative 1. And those are exactly the coordinates of f. So this is the line we're working with. So since f lies on this line, we can say that f has coordinates some x value, and then whatever that x value is, we take a half, and we minus 4. Okay. So now that we vaguely know what f looks like, maybe we should draw ourselves another copy of the picture. D, C, B, A, and then we have sort of a point here. That's N, and then we have a point around here, and that's M. Okay. So we have lots of different choices for F. We could have an F down here. But that's not going to work. We could have an F way up here. But that's not going to work. None of these will work because we have overlap. So, just like before, what we're going to do is we're going to extend B and C, and we're going to say F sort of has to be below these points here. So, this is y equals 4, and this is x equals 5. So F will have to be somewhere in here. So in order for the triangles to lie outside the square, F must be below y equals 4 and to the right of x equals 5. We probably could have or should have made this observation in part A to say that A definitely had to be greater than 5, but I would say the diagram was clear. This question needs less clear. So F is going to have to lie somewhere on the green line. I don't really care where, so we're going to pick just a generic looking point, F. And those are just some awful triangles. CF doesn't even really exist. So let's try again. We'll just make F really big. Okay. So we still have bases of 4, and we can work out heights here. So the height of ABF is just going to be the distance from F to 4. So we want 4 minus this F. So 4 minus the y coordinate. So 4 minus 1/2 x minus 4, which is 8 minus 1/2 x. The height of CBF is going to be the x-coordinate of f minus 5. Right? Because when we say it's got to be below f, that means the y-coordinate, when f has to be below y equals 4, the y-coordinate of f has to be less than or equal to 4. And when we say it's got to be to the right of x equals 5, that means the x-coordinate of f has to be the bigger value between 5 and x-coordinate of f. So we want positive values here, otherwise our equations make no sense. So now we have the height of the two triangles. We know their bases are 4. So we have an area of 16, and we want to add on ABF plus CBF. When we add those two together, we should get a value of 16. So 1/2 base times height, 8 minus 1/2 x, plus 1/2 base times height, x minus 5. So really quickly, the half and the 4 will cancel out, and we'll be left with 2, 8 minus 1/2 x, plus 2, x minus 5. We get 16 minus x, plus 2x minus 10, and that becomes 6 plus x, and we need this to be equal to 16. So x is going to be equal to 10. And we're not asked for just the x-coordinate, we're asked to determine the coordinates of the point f. So we need the y-coordinate as well. Well, how do we figure out the y-coordinate? Well, the y-coordinate was 1/2 x minus 4. So that's 1/2 10 minus 4. So 5 minus 4 equal to 1. So 10 and 1. And if we wanted to, we could go back and we could check things like, hey, does that actually lie below y and to the right, y equals 4 and to the right of y equals 5? Do these heights make sense? Okay, well in this case we're going to get a height of 3, not something like -3, which would have thrown our calculation off. And here we're going to get a height of 5, and that also makes sense. No negative heights, no 0 heights, nothing like that. So this point f definitely does make sense, and we could go a little further and actually calculate with those heights the individual values of the area ABF and CBF, but I think we've sort of done enough. So we have 10, 1 is the coordinates of f, and I think that's all we were asked for. Absolutely. So once again, I'd like to reiterate, I'm not going to be doing the extensions unless there's major demand for them, because they don't have extensions in any of the Freyr, Galois, or Hypatias in any of the later years. This is sort of an experiment, and then they realized, oh, we shouldn't leave the extensions, the hard parts of the problems out. We should just sort of keep them in the questions that they have. And thus the actual Freyr, Galois, and Hypatia that we're familiar with were born. So rather than having questions with A and B, we now have questions that have A, B, and C, A, B, C, and D. I've yet to see an E, although maybe my memory is just failing me. But that's the 2003 Galois, the very first Galois. So join me for more Galois papers, or join me when I go through the Freyrs if you found this too hard, or the Hypatias if you found this too easy. Either way, feel free to subscribe for more videos, and if you like this first Galois, if you like writing the Galois in general, feel free to throw a like on the video, and no matter what you do, I'll see you guys in the next math video. So, thanks for watching.